tcpdump is a super popular lightweight command line based utility that you can use to capture and analyze packets. tcpdump uses the open source libpcap library. That's a very popular packet capture library that's used in a lot of packet capture and analysis tools. tcpdump also supports writing packet captures to a file for later analysis, sharing, or replaying traffic. It also supports reading packet captures back from a file. tcpdump's default operating mode is to provide a brief packet analysis. It converts key information from layers 3 and up into human-readable formats. Then, it prints information about each packet to standard out or directly into your terminal. It does things like converting the source and destination IP addresses into the dotted quad format we're most used to, and it shows the port numbers being used by the communications. Let's quickly walk through the output of a sample tcpdump. The first bit of information is fairly straightforward. It's a timestamp that represents when the packet on this line was processed by the kernel in local time. Next, the layer 3 protocol is identified. In this case, it's IPv4. After this, the connection quad is shown. This is the source address, source port, destination address, and destination port. Next, the TCP flags and the TCP sequence number are set on the packet, if there are any. This is followed by the ACK number, TCP window size, then TCP options, if there are any set. Finally, we have payload size in bytes. Remember these from a few lessons ago when we covered networking? tcpdump allows us to actually inspect these values from packets directly. I want to call out that tcpdump by default will attempt to resolve host addresses to host names. It'll also replace port numbers with commonly associated services that use these ports. You can override this behavior with the -n flag. It's also possible to view the actual raw data that makes up the packet. This is represented as hexadecimal digits by using the -x flag, or capital X if you want the hex and ASCII interpretation of the data. Remember that packets are just collections of data or groupings of ones and zeros. They represent information depending on the values of this data and where they appear in the data stream. Think back to packet headers and how those are structured and formatted. The view tcpdump gives us lets us see the data that fits into the various fields that make up the headers for layers in a packet. Wireshark is another packet capture and analysis tool that you can use, but it's way more powerful when it comes to application and packet analysis compared to tcpdump. It's a graphical utility that also uses the libpcap library for capture and interpretation of packets, but it's way more extensible when it comes to protocol and application analysis. While tcpdump can do basic analysis of some types of traffic, like DNS queries and answers, Wireshark can do way more. Wireshark can decode encrypted payloads if the encryption key is known. It can identify and extract data payloads from file transfers through protocols like SMB or HTTP. Wireshark's understanding of application-level protocols even extends to its filter strings. This allows filter rules like finding HTTP requests with specific strings in the URL, which would look like HTTP request URI matches Q equals Wireshark. That filter string would locate packets in our capture that contain a URL request that has the specified string within it. In this case, it would match a query parameter from a URL searching for Wireshark. While this could be done using tcpdump, it's much easier using Wireshark. Let's take a quick look at the Wireshark interface, which is divided into thirds. The list of packets are up top, followed by the layered representation of a selected packet from the list. Lastly, the hex and ASCII representation of the selected packet are at the bottom. The packet list view is color-coded to distinguish between different types of traffic in the capture. The color-coded is user configurable. The defaults are green for TCP packets, light blue for UDP traffic, and dark blue for DNS traffic. Black also highlights problematic TCP packets, like out of order or repeated packets. Above the packet list pane is a display filter box, which allows complex filtration of packets to be shown. This is different from capture filters, which follows the libpcap standard, along with tcpdump. Wireshark's deep understanding of protocols allows filtering by protocols, along with their specific fields. Since there are over 2,000 protocols supported by Wireshark, we won't cover them in detail. You may want to take a look at the supplementary readings, which shows a broad range of protocols understood by Wireshark. Not only does Wireshark have very handy protocol handling and filtration, it also understands and can follow TCP streams or sessions. This lets you quickly reassemble and view both sides of a TCP session, so you can easily view the full two-way exchange of information between parties. Some other neat features of Wireshark is its ability to decode WPA and WEP encrypted wireless packets if the passphrase is known. It's also able to view Bluetooth traffic with the right hardware, along with USB traffic and other protocols like Zigbee. It also supports file carving, or extracting data payloads from files transferred over unencrypted protocols, like HTTP file transfers or FTP. And it's able to extract audio streams from unencrypted VoIP traffic. So basically, Wireshark is awesome. You might be wondering how packet capture and analysis fits into security at this point. Like logs analysis, traffic analysis is also an important part of network security. Traffic analysis is done using packet captures and packet analysis. Traffic on a network is basically a flow of packets. Now, being able to capture and inspect those packets is important to understanding what type of traffic is flowing on our networks that we'd like to protect.